All right, I've got a couple emails now about the tornado warning that was just issued, and I'm stepping out of my comfort zone here. I'm usually doing winter storms, right? So, all right, let's talk about this. So, right now in New York State, we have this really strong, people want to call this a front. You can call it a front that's cutting across the state. I think it would be called a squall line. The front actually seems to be on radar a little bit further back, but regardless, so there's this like really strong line of storms that's cutting across New York State right here. And in general, that's not going to warrant a tornado warning, but there's some things we have to be aware of. So like the last week has been characterized in upstate New York and most of the Northeast by like very high temperatures. That humidity is really high in the atmosphere, and when you have high temperatures paired with like high water vapor or high humidity, there's going to be a lot of like latent heat energy in the atmosphere, a lot of energy in the atmosphere, and then you have this cold front moving in, and a cold is more dense, so cold's going to move through. It's going to push all of this hot air with a lot of moisture up. When that cools, it's going to rain. We can go into all that, but it's the moving up of the air that is important. When air moves up, it doesn't go in a straight line. Actually, when air moves, the atmosphere moves in general, it doesn't go in a straight line. But when air moves up, it's going to spin because the earth is spinning. When air moves down, it's going to spin because the earth is spinning. Or when the air is moving in a horizontal way, it's going to spin as well, from one latitude to the next, for example. Um, because Earth is rotating, the atmosphere does not move in a straight line. It moves in a curved path. It's called the Coriolis. And people are familiar with this with like their toilet bowls flushing, or if you look at weather maps, looking at like hurricanes or something, like the atmosphere has a tendency to spin. And so when we see a really strong squall line or front moving through, we know that there's a lot of energy associated with this. When we know that the atmosphere is very warm and filled with moisture, we know there's a lot of opportunity for convection and lift here. We know that there's potential for spin. And then when we start to see the spin on radar, that's when we get concerned, and these tornado warnings are issued. So let me see if I can find a couple. These are called, right, so here, like, got some, these are called bookend vortices. I think it's been a while, but like when we start to see spin or rotation on radar, that's when we start to like, right again, like right here, right there. See if I can kind of, here's the Great Lakes, right? Like, see if I can just get out of this for a second. All right, let's get back in. Yeah, like right there is a good example. Right there is a good example. Kind of in there a little bit. Oh, down below. I mean, again, a good one here. Right there, good example. So we're starting to see potentially what could be some spinning of the atmosphere. And so I just have to be clear here. A tornado warning does not mean there's a tornado. It just means that like all the ingredients to make the dish are sitting out on the counter. And now like, does the dish get made? Who knows? Did we get a tornado? It's unclear, but the ingredients are there. The atmosphere has a lot of energy in it. We've got this strong kind of squall line or front moving through, and we're beginning to see some vorticity on the radar. So that's the situation that we have going on here. Do we get a tornado? Who knows? But the ingredients are there.